hydrocarbon is an organic compound made of nothing more than carbons and hydrogens. It is possible for double or triple bonds to form between carbon atoms and even for structures, such as rings, to form. Saturated hydrocarbons have as many hydrogen atoms as possible attached to every carbon. For carbons on the end of a molecular chain, there can be attached. For carbons in the middle of a chain or a ring, two can be attached. For a carbon atom all by itself, 4 hydrogen atoms can be attached. Saturated hydrocarbons have only single bonds between adjacent carbon atoms. Unsaturated hydrocarbons have double and or triple bonds between some of the carbon atoms. Hydrocarbons are classified on the basis of the nature of the framework of the carbon chain in a molecule and on the basis of the nature of bond between carbon atoms. Acyclic hydrocarbons. These are compounds of carbon and hydrogen in which the carbon atoms are linked in such a manner that they do not form a cyclic system. They are also called open-chain hydrocarbons. Cyclic hydrocarbons are compounds of carbon and hydrogen in which carbon atoms are linked in such a manner that at least one cyclic system is formed. Hydrocarbon derivative is a compound of carbon molecules and at least one other element that is not hydrogen.
Well, I'm going to explain you how to name the alkane group. We had a little problem with the audio of the process, sorry for that, but we use a PowerPoint presentation and I hope it will be easy for you to understand.
Hi, in this video I will show you how to name alkenes.
The first step is you're going to circle the longest chain. You're then going to number them starting from the carbohydrate closest to the double bond. And it doesn't matter if it starts from left to right or right to left. Then you're going to identify the carbohydrates attached to the parent chain. And you're going to name them. The first one will be ethyl because it has 2 carbohydrates. The second one will be methyl because it has 1. The third one will be methyl because it has 1. And the fourth one will be ethyl because it has 2 carbohydrates. Then to start naming them, you need to order by alphabetical order. So we're going to start with ethyl because it starts with an E. You're then going to check where they are located and you're going to write the number in which they were located. In this case, it will be 2,5 and you're going to put D because there's 2 ethyl. So it's going to be 2,5 D-ethyl. You're then going to identify the positions of the methyl, which are 3 and 4. And you're going to write 3, 4, D again because it's 2 methyls. And you're going to write D-methyl. Next, you're going to write 1 because there's only one double bond, and you're going to write eptene, and it's going to be ept because there are 7 carbohydrates, and ene because it's an alkene.
What are alkynes? Alkynes are unsaturated hydrocarbons with at least one triple bond. Alkynes are unsaturated hydrocarbons that contain one or more triple bonds between carbon atoms in a chain. Triple bonds involve the sharing of 3 pairs of electrons. The simplest and most commonly used alkyne is ethine. Nomenclature of alkynes is identical to the one of alkenes. The only exception is the ending. They finish in "ine". Now I'm going to tell you the steps for naming an alkyne. The step number 1 is to name the longest chain, and and it must contain the triple bond. The second step is to number the carbon atoms in the main chain. Begin at the end, which is nearest to the multiple bond. If the multiple bond is at the same distance from both ends, begin numbering at the end, which is nearest the first branch point. Step number 3. Write the full name. Assign numbers to the branching substituents and list the substituents by alphabetical order. Indicate the position of the multiple bonds in the chain by giving the number of the first multiple bond carbon. For drawing the structural formula of alkynes, the process is very simple. The first step you're going to do is to draw the carbons for the parent chain and number the carbons and then insert the triple bond. The second step is going to be to draw in the alkyl groups. The third step is going to be to fill in hydrogens so every carbon has 4 bonds.
I'm going to give you a tutorial about the aromatic compounds. Aromatic compounds. It is common to start by saying that aromatic compounds are compounds related to benzene. It has a unique phenomenon that even if it has 2 double bonds, it makes it very stable. It is called resonance. This property makes that the aromatic compounds are easily recognized by having a ring. These rings are called benzene rings. Before starting, when naming aromatic compounds, the termination will be benzene. In aromatic compounds, you can use the common name method. These are some names: methylbenzene or toluene, hydroxybenzene or phenol, aminobenzene or aniline. Let's start with one substituent aromatic compound naming. The IUPAC rule says substance plus benzenes. No numbers because it only has one substance and we don't have another reference substance. In this case, we have that the structural formula is the normal hexagon with a ring and says CH2 CH3. That means that is ethyl. So it will be ethyl benzene. This one is nitrobenzene. Nitrogen is NaO. So it will be simply nitrobenzene. Common names. Because it's only one substituent, it will simply name by the previously named compounds: toluene, phenol, and aniline, in case the structure has the compound. Let's continue with the 2 substituent aromatic compound naming. One of the methods are use numbers. We have to use the lowest one. Use prefixes ortho 1 and 2, metha 1 and 3, para 1 and 4. We can also use the common name method. Let's continue naming each of the substance. This one is ethyl. This one is hydroxide. We have to name them by alphabetical order. In this case, the first one will be ethyl, that is in common, and the third branch, taking the reference, this one is first, second, third. So it will be 3 ethyl, 1 hydroxide, benzene. But we also have the prefixes method, that is that we can use method because it's in the first one and the third one. So it will be M. We have to abbreviate it. It will be ethyl hydroxide benzene. We have to eliminate the numbers in this example. The other one we have is the common names, that is phenol, because we use it has the hydroxide, so it will be 3-ethyl phenol. In this example, we already have the name of the compound, so we have to do the structural formula. We start with the hexagon, and let's see, is 1-methyl. Methyl is CH3. Then the 4 and the 4 one is 1, 2, 3, 4. It will be propyl, that is say CH2, CH2, CH3. As you can see, the three metals are correct because 1-methyl, 4-propyl. Para is 1,4 and is 1, 2, 3, 4. There's methyl and propyl. And then this one is because toluene is this one, so we only have to name propyl, then the toluene. Let's move to 3 or more substitute aromatic compound naming. There are 2 methods: use numbers or use common names. Well, let's start with this one that already has the name of the compound. We have to start writing the hexagon. Then we have to check. It says it is the ethyl benzene. It's in the third one. The ethyl. It will be ethyl CH2 CH3. And I'll say it's in the fifth. Third, fourth, fifth. It says that in the first one it has the chloride element. It will be the first one, third, second, first, chloride, and the second have bromine. In this example, we already have the structural formula. We have to give the name to the compound. It will, because it have 3 nitrogens, it will be 3 nitrobenzene but we have also a methyl that is in the position 1, starting from this one. It's 1, 2, and 3. So it's 2-methyl, and we only have to add is one nitrogen in the first one, the second is methyl, the third one, and fourth, fifth. So it will be 1, 3, and 5. This compound is also known as TNT. We have concluded with our tutorial about naming all the alkenes, alkynes, and aromatic compounds. Make it easy, make it simple.